Hello and welcome to this lesson on finding probability. So this is simple probability, one-step probability, relatively easy. So we're going to fly through this one relatively quickly, I believe. Since your question says, how do I find the probability of an event? Did you know that probability and odds are not quite the same thing? So when we're talking about probability, we're looking for like the favorable number of outcomes over a total number of outcomes. Where odds is favorable outcomes to unfavorable outcomes. And that means like the probability of rolling a 4 on a dice. I mean, there's 1 4 on a dice and 6 possible things could happen. So the probability is 1 out of 6. But if you're talking about odds, there's still 1 4 on a dice, but there are 5 things that are not the thing you want. So the odds of rolling a 4 on a dice are 1 to 5. So these numbers together should add up to the total. The only time that wouldn't work out is if it would simplify, like getting an even. An even number probability is 3 over 6, which is 1 half. You've got a 50% chance of getting an even number. If you're talking about the odds of getting an even number, that is, even numbers. There's 3 even numbers, 2, 4, 6. There's 3 not even numbers. That is 1 to 1. This can still simplify if these guys have common factors. This is considered a 50% chance. 1 to 1 means both sides are even. The chance of you getting it and the chance of you not getting it are the same. Where this lets you know that the chance of you not getting the thing you want is higher than the thing you actually do want. So just throwing it out there that odds are not quite the same thing as probability, although they're very close. So we have a couple little vocab words here. We have an outcome, which we've actually already mentioned. That's just something that could happen, a possible result of an experiment or of an action, rolling a dice or flipping a coin or thing. An event is an outcome or a collection of outcomes. A couple things could be one event. Sample space is a set of all possible outcomes. That can be written as a list, where you could just list all possible things that could happen. And then the probability of an event is the measure of the likelihood or chance. Sometimes we write it as a fraction. Sometimes we write it as a percentage. Or we could even write it as a decimal. So it's a likelihood or chance as a fraction, decimal, percent that an event will occur. Formulas. So these formulas, these two are pretty much the same thing. The difference is when you're talking about theoretical probability, in theory, what should happen? Well, if you roll a dice, in theory, you should get a 3, 1 out of 6 rolls. Because there's 6 sides, and if everything's even, you should get a 3, 1 out of the 6. That's in theory. In practice, if you actually do an experiment, that may not happen. If you're running an experiment and you roll a dice 10 times, number of trials is 10. If you roll the dice 10 times and you get a 3 only 2 of those times, then this is the experimental probability based off your experiment, what has happened. Where in theory, you could do this before you even roll any dice. You could just, based off the object you're looking at, what's the chance of you getting the thing you want. So finding a sample space. Basically, this first part is being able to determine how many possible outcomes there are. How many possible outcomes are there if you flip a coin and roll a dice? Do you know? Well, and it says here to list all possible outcomes. There are 12. You can get a heads with a 1, 2, 3, 4, 5, 6. So heads on the coin, 1 through 6 on the dice. So right here, that's 6 possible outcomes. Heads 1, heads 2, heads 3, heads 4, heads 5, heads 6. You could also get tails and 1, 2, 3, 4, 5, 6. So that gives you a possible 12 outcomes. And the way you can figure this out, it is going to be a multiplication. It is how many possible things could happen with the coin flip. Well, there's 2 things that could happen, heads or tails. How many possible things could happen with the dice? There's 6. If you multiply those outcomes together, because each of these are different actions, you would get 12 possible things could happen. And here's the list. I made it more of a table, which is perfectly fine, but there's a list of all possible outcomes. A bag contains 2 red marbles and 3 green marbles. How many possible outcomes are there for picking a marble from the bag and flipping a coin? List all possibilities. Okay, so from the bag, so how many possible outcomes for picking a marble from the bag and flipping a coin? Well, how many marbles are in the bag? There are 5. How many options are there when you flip a coin? There are 2. So I say there should be 10 possible things that could happen. So I'm going to make that table again for listing my possibilities. So I have heads, tails. So I can get red marble number 1 or red marble number 2. Green marble number 1, green marble number 2, or green marble number 3. And because I'm lazy cheater, I'm just going to copy and paste. There's all my possible outcomes. So I can get tails at the first red marble, tails on the second red marble, tails on the green one, green one, green one. That gives us 10 possibilities for picking a marble from the bag, just any marble. There's 5 of those, and flipping a coin. And there's 2 options there. Okay, 2 for me, 1 for you. How many possible outcomes are there for flipping 3 coins? And if you could please list all your possible outcomes. Go ahead and pause the video and do that right now. All right, so what do we got here? So you should have come up with 8 possible outcomes. So you would have boom, boom, boom. There's 3 different actions. You flip the first coin, you flip the second coin, you flip the third coin. That gives you 8 possible outcomes. Now, as far as listing your outcomes, you can even just make a straight up list like heads, 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 tails, heads, tails, heads, heads, tails, tails. That's all the possibilities with getting a heads in the first flip. Then tail, ooh, that was supposed to be a tails. Tails, heads, heads, tails, heads, tails, 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 heads, tails, tails, tails. So that's every possible combination of flipping those 3 coins. There's 8 of them. There's 2 options for the first one, 2 options for the second, 2 options for the third. You multiply those options together, giving you 8 possible outcomes. And this is known as the counting principle. I could expand a little bit on this. Like if I used to teach like 7th grade, I'd teach this. If you're going to lunch and you had a lunch menu and you have 5 choices for lunch and you have 3 choices for drink. So let's say 5 choices for the main meal, 3 choices for drink, 2 choices for fruit, and I don't know, 3 choices for a snack. And I would say, well, how many possible lunches, if they just served the same thing every single day, how many possible lunches could you have? Well, if you multiplied each of these together, that would give you the total possible lunches you could get. And it looks like that's going to be 90. 5 times 3 is 15, times 2 is 30, 30 times 3 is 90 possible lunches just from those 5 main meals, those 3 drinks, those 2 fruits, and those 3 snacks in different combinations. Okay? So, just another side problem. Theoretical probability. Samantha has a bunch of pillows at her house. She has 3 blue pillows with flowers, 5 red pillows with flowers, 2 blue pillows with kitties on them, and 6 red pillows with kitties on them. What is the theoretical probability of picking a pillow with flowers on it? Okay, so normal probability is the thing you want over total. That's the fraction. That's what I have in my head, the formula for probability. Okay, so now the thing we want is flowers. How many pillows are there that have flowers on it? There are 2 here. Let me make that much bigger. There are 2 here. Oopsie, not those 2. So 3 with flowers here, 5 red ones with flowers there. That gives you a total of 8 pillows with flowers. Out of how many total pillows? 8 out of what? Well, there's 8 more that have kitties on them, so that'd be 16. So that would be a 1/2. The theoretical probability of picking a pillow with flowers on it is half, which as a decimal is 0.5, and as a percent is 50%. To change this to decimal, you divide. To change your decimal to a percent, you either multiply by 100 or you move your decimal over 2 places. They both do the same job. What is the theoretical probability of rolling an even number from a single dice? Actually, this is an example I gave earlier. It would be, the theoretical probability would be, well, eventually 1/2. It would be 3 out of 6. If you're looking at a dice, that's even, that's even, that's even. So 3 out of the 6 of them are even numbers. And if you can, you should always simplify your fractions, which again is 0.5 or 50%. It's a good habit to list your percentages or your probabilities in the different forms. Make sure you can change from one to the other. Abigail's doll collection has 2 girls wearing blue dresses and 2 boys with red hats and 2 girls with green skirts. What is the theoretical probability of randomly picking a boy doll? I would like you to do this one, please. Go ahead and pause the video and find the theoretical probability. Okay, theoretical probability of getting a boy doll, the thing we want over our total. So we want a boy doll, and there are 2 of them. Those 2 right there are the only 2 boy dolls. Out of a total of 6 dolls total. There's 2 here, 2 here, and 2 here. Simplifying our fraction gives us 1/3, which is 0.33 repeating, which is 33.3%. So each of these are technically right, but you never know what form the question is going to ask for. Like here, it doesn't say as a decimal or as a fraction or as a percent, but there are times where it may just, you may say, what's your answer as a percent or as a decimal or as a fraction. Okay, so that's theoretical probability. That's just what should happen. Experimental probability is probably based on what has already happened. It says here, James has flipped a coin 100 times. He got heads 21 times and tails 79 times. What is the experimental probability the next toss will be heads? What is the theoretical probability the next toss will be heads? Okay, so based off the experiment, the formula is still kind of the same. It's the thing you want over total. Well, we want heads to happen. That currently has happened 21 times based off the experiment, out of a total of 100 flips. That is the experimental probability of getting heads on the next flip. That doesn't really simplify. I mean, 0.2 or yeah, it should be just 0.21. 21 divided by 100. It's 0.21, which is 21%. Okay, that's the experimental probability. Now, theoretical, assuming this is a fair coin, which we don't know. I mean, looking at this, I wouldn't guess this is a fair coin. That's a pretty big difference here. But assuming it's a fair coin, the coin probably has one side that's heads out of two sides total. You know, coins have two sides. So the theoretical probability is still that 50%. So these don't have to be the same based off your experiment. What should happen? A bag contains many marbles. So we don't actually know how many marbles. Many marbles. Abby pulled a marble from the bag, recorded the color, and put it back in the bag 25 times. She got red 6 times. She got blue 15 times. She got green 4 times. What is the experimental probability the next pull is green? Okay, so let's answer that first, and then we'll go to the second part. So, well, the thing we want, the green, has only happened 4 times out of 25 pulls. That would be the experimental probability. 4 out of 25. And I'm not sure what that is. Okay, so that's 0.16, which is 16%. So that's the experimental probability of getting a green marble. Suppose Abby pulls a green marble. What is the experimental probability the next pull is blue? Oh, okay. Well, how many times has blue happened? Because we're still looking experimental. Blue's happened 15 times out of how many total pulls? It's not 25 anymore because it says now, suppose she pulled the green marble. Now there's been 26 pulls happened. And that would give us, I don't know, 0.577. I'm rounding to the nearest thousandths. And then that would be 57.7%. All right, so it's just the thing you want over the total, in this case, experiments. And that's it. How do you find the probability of an event? Go ahead and pause the video, think about it. How do you find the probability of an event? Well, it's the thing you want over the total possible things that could happen. Okay, should be a review lesson at this point. So it's fairly quick, fairly easy. You'll get some more practice, and we'll do some more in the next lesson where it's going to get a little harder. Not a whole lot, but it will definitely get a little harder in the next lesson. Okay, thank you so much for watching. Until next time, toodles.